wait for one more minute and then we can start the session. Hi Nagraj, can we start the session?
Raghavan, wait 2 more
Yeah,
minutes.
we'll wait for 2 more minutes and then we can start. We'll start exactly at, now the time is 7:33 UAE time. 7:35 we'll start. Good evening everyone. Thank you each and every one of you who have taken time and effort to join this webinar, and welcome to 17th webinar of TIECONN. So what is TIECONN? So TIECONN is a global initiative led by industry professionals built to uplift the engineering community to technical empowerment. We focus on major things. One is the technical webinar and expert panel discussions. We focus on the key problems which is currently there in the market, and then we address it by inviting the experts, and we give a solution. Second is the technical workshop. Like this, we conduct each and every month. We started in 2025, and then we conduct every month a technical workshop, and also career guidance and mentorship with the senior professionals. And we share the knowledge what we have. That is our main motto. So these are some of the successful webinars which we have conducted so far, and some of the technical workshop where we gather all together, all the industry professions gather all together. We do the networking, and we do the technical webinars and the presentations. So without taking much time, let us go to the webinar. I would like to thank Mr. Harsh Bardhan to accepting our invitation, and accepting to conduct a webinar on it's a very critical topic. It's psychrometrics. So today our topic is advanced psychrometrics in real world applications. Mr. Harsh Bardhan is an HVAC technical consultant, R&D expert, and innovation leader with over 25 years of experience in advanced thermal management, air handling systems, and product development. He has led the development of innovative HVAC technologies, including India's first IoT-enabled air handling units, worked extensively on international certifications such as Eurovent, AHRI, AMCA, UL, and ISO, published author, and regular technical speaker, and passionate about translating psychrometric theory into practical engineering solutions, helping industry professions design more efficient, reliable, and sustainable HVAC solutions. Thank you so much, Mr. Harsh Bardhan. Over to you.
Thank you, Raghavanji, for such a great introduction. A couple of more things. I have authored more than 400 articles on LinkedIn, and published almost more than 4 or 5 research papers now. And my upcoming book is under review by by HVAC committee team people. And my book talks on AI controlled adaptive thermal management, and it's a very deeply researched topic on a couple of parameters, like how AI should be implemented, what all the like algorithms, and which algorithm should be selected, and what it did to be selected as the best algorithm. And the third research topic is that what all the algorithms that it can throw the security challenges. So this has been in the making for almost like more than 2 years now, and finally the time has come for it to be published. So once the book is reviewed, it will be published, and this will be my first book, just to share with the community. Uh, Coming back to the topic, let's start with the presentation. I'll share my screen so that like the people can see the entire presentation, and then from there onwards, like we can take it to the next level. So
Yeah.
I'm just going to. Is my screen visible to everyone?
Yeah, we can see your screen.
Oh, thank you, Ramanji. So, once I was going through, a lot of, questions from the complete TIECONN group people, and I was really surprised, the kind of questions that they threw. And I tell you, those are very challenging questions, and it took me a lot of time to kind of, like do the research work on the development of the complete, technical article, and then, in development of this advanced psychrometric presentation. Uh, this entire presentation is almost like 45 slides long, and it covers some of the best in-depth knowledge sharing sessions, which I have worked on practically. And along with the practical, there are a couple of more challenges which I'm still fighting in terms of the psychrometrics. So just to talk on the introduction front, why psychrometrics underpins every HVAC design decisions in the UAE. This is a very critical question. When if you talk in UAE, FHU is designed on different temperature, and then the actual temperatures are very different. So all those questions, I have already included, and I have answered, and I have written, some of the posts which are already shared on LinkedIn, along with my WhatsApp channel. So moving on, why psychrometric is the language of HVAC. Now, if you talk of like psychrometrics, every HVAC outcome, comfort, energy use, or if you live inside a building, which is may fall within the syndrome of like sick building syndrome, the mold risk it occurs, and ultimately the corrosion. These are all moisture properties, and if dehumidification or proper humidification is not done, then you will incur all this risk. So second point here is like a single psychrometric chart replaces pages of thermodynamic tables with one visual quick reference. You don't have to send so many pages of write-ups to the engineers, those who are working in the field. And one psychrometric chart will explain to them like what should be actual the value. And then of course design, tab, commissioning, and building management system, that is BMS teams, must all read the same chart the same way to avoid the conflicting decisions on the site. There are a lot of working closely with some of the people on the sites, everybody has got their own opinion, and everybody deciphers like the way they want to interpret the entire data. But what this psychrometric chart does is it will give you the state points, and from the state points you cannot have any other meaning than to kind of read that those state points only. So the fourth point here is the most mystery HVAC companies, that is sweating, diffusers, sticky flows, high energy bills, they resolve quickly once plotted on the chart. So this gives a clear picture as to which property should be removed, and what all the countermeasures that needs to be taken to tackle the issue. So why psychrometric is the language of the tool? The key takeaways from this would be think in state points, not just temperature. Temperature can be anything, but the points are very constant. Every process on a chart is a straight line. Fluency here prevents costly field disputes. The more fluent your chart is, your chart will clearly explain that this is the point, and the field people, those who are deployed on sites, they will not have any other option than to kind of set on one point, and then read that point as that point only, not any other point. So here I have quoted the example as If dew point is, or rather, if what do you say, your dry bulb temperature is, 28 points, 28 degrees C, and your RH is 55 degrees C, then the dew point accordingly you can plot here and you can see. Now this is very unambiguous data. Nobody can decipher. But if you write that, probably this would be the scenarios. Everybody will have a different points of view on the interpretation. So this brings a lot of clarity, in thinking in terms of the state points, not just temperatures and not just chart wise or thermodynamic tables. Whereas in terms of the data points on the state points. So this is why the psychrometric is the most important language of the HVAC. Moving on, why it matters more in UAE buildings. If you look at comfort air conditioning, it's a very high coincident humidity, often 55 to 65% RH outdoors, means dry bulb temperature alone cannot define comfort. Occupants feel humid, humidity, not just heat. I mean, the sticky feel inside if you go into UAE buildings, and if the RH factors are not correctly designed, and you just take the reading for the dry bulb, then you are not going to actually do the justice to the entire solution. Then energy bills, latent loads from fresh air can exceed 40% of total cooling loads in the UAE. Sizing on sensible heat alone under designs dehumidification capacity. Then the third one is indoor air quality. Ventilation rates under ASHRAE 62.1 must be delivered without importing excess moisture that fuels microbial growth. Of course, ASHRAE 62.1, and ASHRAE is coming up with another standard data. That is another, measurement tool, that is called indoor environment management. So they have included, but of course, ASHRAE indoor, 62.1 it talks on, temperature and humidity controls. But IAQ, it talks on great other parameters. This is the latest development which ASHRAE has already published. So, moving ahead, moisture control is very important factor out here in the UAE buildings. Condensation on ducts, grills, and structure is the number one recurring UAE HVAC complaints. Nearly always is psychrometric and not equipment failure. As we move along the presentation, I'll explain to you some very critical fundamental flaws, and one of the buildings, how they had the problem and what was the solution. And they were trying to replace the insulation material just to control the condensation of the grills, but actually that was not happening. The problem was somewhere else. So as we move in the slides, you will understand what I mean to talk on those topics. Then this session is divided onto fundamentals, that is the 8 core properties. Then second is the reading the chart. It defines upon state points, processes, a work mixing example, like how two streams are mixed and what would be the resultant psychrometric property of that particular air stream. Then UAE field questions, a lot of time, I wrote a lot of posts on this FHO design, then electric heaters, why it leads to increase in the sensible heat, and the moisture is not removed. Then the condensation issues, how the condensation is occurring on the grills, etc. Then heat recovery comparison, and then IOK, of course. Design tips and case studies, common mistakes, and 2 real project discussions I've already included in the presentation, which we'll be discussing. Then, of course, the last and the final one is the summary and the Q&A answer session. I'll open the session, 15 minutes after we have completed. And, we can have, question and answer session. If you ask me any question, I can just answer your questions live, So now let's move on to the quick refresher on psychrometric fundamentals. I'll be discussing 8 properties, which I feel that, every HVAC engineer must be fluent in, So moving on, let's start with the first property, dry bulb temperature. everybody knows about the dry bulb, and of course, TIECONN has done a very good job in sending the basics of the complete, psychrometric, and they have covered a lot of points in that, and those points are really valid and very good points. But just to cover you up here, so that like the people those who have not read the charts and the slides, I'm just covering it up for them, just to refresh your knowledge base. So definition is like temperature of air measured by an ordinary thermometer, unaffected by moisture content. Dry bulb will be 100% dry in nature. No moisture content should be recorded on the dry bulb temperature. Then measurement, how do you measure it? It is using a standard mercury or RTD thermometer with the bulb shielded from radiation and moisture. Mind it, radiation and moisture is very critical to be. This bulb should be shielded from. An application forms the horizontal x-axis of the psychrometric chart, used for thermostat set points and the coil selection sizing. So dry bulb temperature becomes very critical. If you want to go for dehumidification or humidification, or like the sizing of the entire unit, then dry bulb temperature has a property. It helps you a lot in cooling coil sizing. Then wet bulb temperature. I'm not drilling down in great details because I don't want to take more of your time. So I'm just brushing it up. Most likely, I think this presentation will be there on my LinkedIn profile, so anybody can download it and refer to this presentation at later stage. Or you can just send me a connection request, and I'll approve that, and then you can download it from there as well. So, okay, so coming down to the next point is the wet bulb temperature. Definition of it is, temperature read by a thermometer whose bulb is wrapped in a wetted wick exposed to moving air. So this is like the entire wick is covered. The wick is covering the, like a bulb, and it is continuously it is exposed to the moving air, and then accordingly, the temperature recorded would be the wet bulb temperature. The physical meaning is, the lowest temperature air can reach through evaporative cooling alone at constant pressure. The pressure should be constant. That is, isobaric conditions has to be maintained here. So then evaporative cooling relationship, wet bulb temperature equals dry bulb temperature only at 100% RH. Now this is a very critical property, which I'm talking about here. The gap between dry bulb temperature and wet bulb temperature widens as air gets drier. This gap is the evaporative cooling potential. See, if you are, in what conditions would the, this can be a very good question for, the people to answer, what will be the condition where, WBT and DBT would be 100% equal. So the condition would be only 100% RH. But mind it, RH values are, not absolute in nature. One, a degree rise in DBT, and the RH value can slide to 50 degrees, 60 degrees, 70 degree. So basically, it depends upon, the humidity content inside. How much is the humidity content, and accordingly, the wet bulb temperature is, defined. So as the webinar progresses, as the knowledge session progresses, you'll be able to understand what I mean by, even 1 degree rise in dry bulb temperature can increase or decrease your RH values. So it's very it's not good to compare two RH values or at the same temperature. If the temperatures are different and the location is different, then the humidity ratio is different, and because of the humidity, your dry bulb temperature, or the even though your dry bulb temperature remains the same, your wet bulb temperature will decrease or increase. So that is how the entire thing is. So let's move on. What is the relative humidity? Relative humidity is the ratio of the actual water vapor present in air to the saturation vapor pressure at the same temperature. So ASHRAE 55 recommends 30 to 60% RH indoors. That is, your IUQ criteria as per ASHRAE 55. And above 60% promotes microbial growth. If you take RH above 60%, then if you put more water content inside the buildings, and if more water vapors are present in your atmospheric condition, and 100%, like in UAE conditions, microbial growth will occur. Below 30% crosses dryness and discomfort. So the most, comfortable range is only between 30 to 60%, Here, one critical caveat I would like to impart to the audiences is that, RH changes with temperatures, as I was discussing in my previous slides, RH changes with temperature even if moisture content is constant. RH will change with the temperature. Never compare RH values at two different temperatures directly. So this will be a critical caveat, and why that thing happens is only because, your relative humidity will vary. So that becomes your wetboard temperature, because of which the RH values will be very different, So here the formula for the RH is, PV upon P saturation upon into 100. So this 100 is added just to define in terms of the percentage, And PV is the actual vapor pressure, and the PSAT is actual saturation vapor pressure at same dry bulb temperature, So this is what the relative humidity is. Now let's talk about the dew point temperature. The definition of the dew point temperature is, the temperature at which air becomes saturated 100% RH. If cooled at constant pressure, no moisture added or removed. So, the basic definition would be, if I were to put it in other language terms, is, the temperature at which the saturation of the, air starts to happen and it begins to condense. So, like, the moment condensation forms on the coil point, that particular point would become the dew point temperature for that particular, air. Of course, what I mean by that particular, air is that, at different locations, the dew points would be very different. Say in Delhi, we'll have something different, in Ahmedabad will have something different than, like in UAE we'll have something different, like in California we'll have some different dew points, etc. So the why it is important is that, it depends only on the moisture content. Unlike RH, dew point does not change with dry bulb temperature. And condensation, any surface at or below the room's dew point. Let's say your room temperature is, very different compared to, the surface of the grill, or, the area from where, you are getting the filtered air, or, like the condensed air, or, the processed air. If the temperature differences are too high, then of course the moisture will form on the, grill surface. See, if this psychrometric chart, if you look at, like dry bulb temperature, I have plotted a point here on the, room air that is at, like 24 degrees C and with 65% RH. Here the RH values are high, and the humidity ratio. And if you plot this, if you take it, dew point here would be, like 17 degrees C, and any surface below this, that means, the delta T difference would be, if it is higher, then the condensation would begin to form. So since I have constructed, a lot of companies for Eurovent certification. So if you look at Eurovent certifications complete guidelines, they clearly like they talk in EN 1886, how much should be the thermal bridging and like thermal transmittance criteria. And they have got very strict monitoring policy. So their standard, as per EN 1886, it clearly defines that any difference of like 20 Kelvin, the condensation will begin. So here the same. This is the dew point, and it is referring to that point only. Like, we have got air handling unit inside where the temperature is 10 degrees C or something like that. And if outside temperature is 20 degree, 30 degrees or 40 degrees, and if the difference is too high, then the condensation will begin to form here. The moisture vapor will attract. That is why the thermal bridging is provided in double skin air handling units as well. So moving on to the next slide, humidity ratio, very specific, humidity. This is also called, absolute humidity. Both I use both the terms, absolute humidity or specific humidity. With the specific, it is per kg. That is the word specific means. So what would be the definition? The definition of like a specific humidity is the mass of water vapor carried per unit mass of dry air expressed in kg or grams of moisture per kg of dry air. This is very critical, per kg of dry air. That this point has to be remembered. Since forms the vertical y-axis of the psychrometric chart. The only moisture metric that stays constant through pure sensible heating or cooling. This will not change. Say if you have got your state points, 2 state points at the psychrometric chart, and you are measuring the specific humidity or humidity ratio, then this will remain constant. It is the actual amount of water vapor that is present inside the air at that particular point of time, and the actual it is measured in terms of either grams or kilograms of that particular moist air. Say for example, if you have got an AHU and which is delivering 1500 CFM, then for the 1500 CFM, how much would be actual grams of water vapor that would be present inside, to attain your RH value of 30 to 60%. So that criteria can be calculated. So all those of course as we advance, you'll see the calculations as well, how it is calculated. So here the formula is specific humidity or humidity ratio is equal to 0.622 into PV upon P saturation, P atmosphere minus PV. Here, humidity ratio, that is omega, is in kg water or per kg of dry air, and the P saturation is the total atmospheric pressure. So moving on to the next slide, enthalpy. It's the total heat content of the moist air per unit mass of dry air, the sum of sensible heat temperatures and the latent heat moisture. So if you look at the air, air is basically composed of two elements. One is the a dry air part, and the second is the moist air part. So dry air part, we measure it with the help of the sensible temperatures, and the wet air part, that is the the moisture content of the air, that we call it as latent heat. So these are the two components. Sensible plus latent will form the enthalpy of the complete system. Practical HVAC calculations are coil selection software and manual load calculations both use the enthalpy differences between entering and leaving air to size cooling coil capacity. So this is why enthalpy is very important criteria. And the chart use, it's a diagonal enthalpy lines on the chart. Let you read total heat removed by a coil directly without separating sensible or slash latent formulas. And the formulas for the enthalpy is H is equal to 1.006 T plus omega and 2501 plus 1.86 T. Which is where H, that is the enthalpy, is in kilojoule per kg of dry air. That is T is in degree C, and omega is in kg of water per kg of dry air. So of course in the end of the this presentation you'll get a cheat sheet, so all the formulas will be covered in those cheat sheets. So even if you're not taking down the notes, don't worry, you'll have a handy printout ready for you to kind of go ahead. Moving on, sensible heat and sensible heat ratio. Sensible heat definition: heat that changes air temperature without changing its moisture content, moves the state point horizontally on the chart. So sensible heat ratio, SHR is very important when we are sizing the humidification and dehumidification procedures. SHR is the sensible heat divided by total heat. We were discussing about the total enthalpy. If you divide the sensible heat part only with the enthalpy part, then you will get the SHR values. And the SHR values are usually falling from 0 to 1. So higher value of SHR, SHR value of 0.52 is used in seafood processing plants, where continuously water is used for washing of the shrimps and all those type of food items, or even the fish as well. And there very low amount of SHR values are needed, something to the tune of 0.52. But if you talk about data center, the SHR values are close to 1. It's 100% sensible. So with that kind of variations, SHR becomes very critical parameter. Sensible heat and sensible heat ratios become very critical parameters. So here a design impact, a low SHR, high latent fraction, typical for UAE fresh air, demands a coil selected for moisture removal, not just temperature drop. If you can correlate, a low SHR would result in high latent fraction. That means more amount of moisture needs to be removed from the air. And a high SHR value would be, that is like 1, as I was talking in terms of like data center and seafood processing plants. High amount of like SHR value close to 1 would be exclusively applicable for data centers. So the formula that is used here is QS is equal to 1.23 into CFM into delta T. Where QS is in watts, so that is QS is stands for heat supply, in watts, and the CFM is airflow, and delta T in degree C. It is constant for 1.23 for standard air density. So if your air density is standard, then it will become, your delta T would become constant. That is 1.23. So moving on, latent heat and the system processes. This will be probably the last slide for the basics of psychrometrics. The latent heat and system processes. Latent heat definition: heat that changes moisture content without changing dry bulb temperature, moves the state point vertically on the chart. So 5 standard processes we'll use today is like a room process, cooling coil process, reheat process, mixing process, and outdoor air process. Each is simply a straight line between 2 state points. We have already discussed on the slide where I was discussing about the dry bulb temperature. What the 2 state points are. So we will discuss all the points as the presentation moves. And the formula for that is QL is equal to 3010 into CFM into delta W. QL is in watts and the CFM is in airflow, and delta W is humidity ratio change, that is kg per kg. This is the formula that you can remember it for latent heat and system. This formula is very critical when you are talking about dehumidification process. We often use and we deploy this. If CFM is 1500, then humidity ratio change. If this much, then how much was with the actual QL in watts. That is the heat supplied. So moving on with the section 3, understanding the psychrometric chart. I have broken down this into 4 slides. That is anatomy of the chart. Objective here is to give you a brief feel of how the psychrometric chart actually looks like and what it does, etc. So horizontal axis, it talks about dry bulb temperature, degree C, increasing from left to right. If you look at psychrometric chart on the right side of the screen, it talks about 0, then 10, 15, 20, 25, 30, 35, 40, 45 till 50. Is the dry bulb temperature, it's the horizontal line, right? And vertical line, it is humidity ratio. It's grams per kg of the dry air, increasing from bottom to top. So if you just look at 0 and 10 coordinate at the bottom left side of the psychrometric chart, and if you go vertically up, that is 0, 5, 10, 15, 20, 25, and 30. This will form your humidity ratio. And of course, as I have already discussed, it is always measured in terms of grams per kg or kg per kg, whatever parameter that you want to select of the dry air. Then curved saturation lines, the bold upper left boundary, 100% RH, air cannot exist above this line. If you look at those curved saturation lines, the one which is in bold, the curved line, the bold curved line, if you look at, this is 100% RH. and just beside that it is 90%, and beside that it is 80%, 70%, 60%, and so on. So why it is talking about that at 100% RH, that means like you have filled the complete property of the air, and with the water, so air does not have a chance to like exist in that particular psychrometric state. So 100% RH is actually theoretically impossible, but anything people can like deploy, especially with regard to what do you say, defense equipment manufacturing, etc. These some of the like heat measuring properties are deployed. So of course, I'll not get into that part because this is exclusively related only with the like HVAC property, HVAC people. So otherwise into like missile manufacturing and
Yeah, can you please mute yourself? Yeah, thanks.
Yeah, okay, no issues. So in those segments, if somebody refers to my LinkedIn profile, they can see the articles on like my authored articles on conduction and convection of like complete missile systems and all those things. So of course, I'm not getting into that thing. I'm just sticking to HVAC segment only.
Hi sir, can we go to our topic of the solutions, because all the audience are asking for our case studies.
Okay. So I'll just move on, quickly with, I'll just skip these two. I wanted to, like really draw their attention and how to kind of, like locate the points. But, if you want me to skip to the,
sorry, please don't skip. We are eager to hear more from you.
Yeah, sure.
You don't want me to skip?
Okay.
You want me to skip or don't want me to?
Okay,
skip?
we can make it like this. Maybe we can finish off like in a crisp manner this one, and then we'll focus more time on the advanced solution. Yeah.
Okay. I'll be fast with this. I'll not drill down on each and every parameter. Maybe the audience is intelligent enough to understand the core concept. So I'll be very quick. Maybe one line just to brush up your knowledge, and then I'll quickly move on to the next section. Right? Will that be okay, Raghuji?
Yeah, please go ahead, sir.
Yeah. Thank you. Okay, so here you can locate the like two state points, and like you can just follow 1, 2, 3, and 4 step, and you can plot the like reading of the dry bulb temperature and like RH and the dew point. Okay, so you can just see from here like how I have plotted it, and like how humidity ratio is defined, etc. So moving on to like next slide. Sensible heating, horizontal, and like you can see that like all the points I've already discussed. So I don't think like I have to narrate much on this slide. And let me move on to the next example. I think this would be interesting for the audiences to understand this. See, if you've got two state points, that is like 46 degree dry bulb temperature and RH is 25 degree, and then like return air is like 24 degrees C and the RH is 50%, and then mixing ratio is 20% OA and 80% like return air. Then how we have plotted is like you can take the psychrometric properties, plot it, and like probably you can, with the help of the psychrometric chart, you can actually drill down on the like what will be the mixed air property when the two streams are mixing. One is at 46 degrees C and another one is at 24 degrees C. What would be the resultant of the like the two streams when it is mixed together? This can very easily be identified with the help of like psychrometric chart. I'll move on to the section 4 of like practical HVAC applications in the UAE. I have written a lot of articles why the FAHUs in the UAE generally designed for 34 degrees C and dry bulb temperature is like at 32 degrees C. Wet bulb instead of like a peak 46 degrees C dry bulb and 30 degrees C in wet bulb. because coil sizing should follow ASHRAE 0.4% coincident design data. What you mean by 0.4% coincident design data is that, see, you have got conditions of 46 degrees C and like 30 degree C wet bulb temperature, which is only 0.4% of the year, and that is only for the 35 hours at the max as per the ASHRAE data publications. So that is why FHUs are usually designed. But second point is equally valid, that very high enthalpy is generated at 34 and 32 compared to 46 and 30. If I were to just read you this, the 46 degree reading is an extreme low humidity peak that occurs only for handful of hours annually. I'll as my presentation, as my it moves, you'll see it is only for 35 hours per annum that this temperature is reached. And whereas 34 and 32 reflects the coincident wet bulb conditions used in ASHRAE 0.4% annual design data, the conditions that governs total, not just sensible coil load. And the designing for rare peak inflates capital cost without meaningful improving comfort during the hours that mattered. So I have just compared this, psychrometric and cooling coil load comparison. So here, two parameters I have taken into account. Parameter, that is the basis, then ASHRAE 0.4% coincident, and then the extreme peak dry bulb temperature. So if you look at this chart, it is talking about annual hours at / near conditions is only 35 hours per year, and which is less than 5 hours per year. Extreme peak conditions is less than 35 hours per year. So the conditions has to be selected at 34 and 32, and of course the enthalpy calculations, I've already posted an article, and it really went viral, and thank you for TIECONN people for giving me this question. The very critical parameters are the enthalpy loads are extremely high at this point. If somebody can I'll share maybe my screen later, not now, because that will break the rhythm of the entire presentation. I have given a complete calculation, how actually at 34 and 32 degree dB and wet bulb, how the enthalpy is affecting and which enthalpy is higher. And we have to size our coils only for FHUs as sized for enthalpy calculations, not for max load conditions. So, and of course the fourth and the final point is here is that part load operating efficiency is better matched, and at 46 degrees C and dry bulb temperature and 30 degree wet bulb temperature is degraded. So accordingly, this psychrometric chart has been plotted. You can see, peak where it is, going, and then ASHRAE 0.4 conditions, where it is going, and then where it is meeting, and what would be the your enthalpy, that is the conditions where it is meeting, etc. So moving on, of course, some recommendations are there. So whenever you take into considerations for the design of in UAE conditions, please, it is my sincere request, use ASHRAE 0.4 annual cooling design data. Put dry bulb and mean coincident wet bulb temperature from ASHRAE fundamentals. That is handbook of climatic data table for the nearest UAE station. And verify against local meteorological records. Cross check with the UAE National Center for Meteorology data, where available for site specific variations. UAE's I was there. Maybe the airport site may have a different kind of meteorological data, and maybe where I was staying, Taj Dubai may have kind of a different meteorological data. Or where industrial area is located, that can have very different meteorological data. So you need to verify that. The size and total enthalpy, the sizing should be based on the total enthalpy calculation. So you have to really calculate based on the location, what sizing, where it is going to be installed, where your FHU is going to be installed, and size that unit according to that particular enthalpy calculation. confirm the coil selection, software evaluation, sensible and latent load at the coincident wet conditions. Then reserve peak tribal for envelope / glazing loads only. 46 degrees C for extreme is approximate for solar and envelope or heat gain calculations, not fresh air coil sizing. So extreme conditions are different, and fresh air coil sizing is very different. So fresh air sizing, it will involve dehumidification as well. So accordingly, we'll have to calculate that as well. So moving on, next question that has been put forward is, can an electric heater in a FAHU remove moisture from the air? The answer is strictly no, it cannot. It adds only to the sensible part, and sensible, once you add the heat, it may increase your dry bulb temperature, but it cannot remove the moisture. So removing the moisture is a very different property. No, an electric heater adds a sensible heat only. Humidity ratio stays exactly constant while RH falls. An electric heater raises dry bulb temperature with zero change in moisture content, which is your humidity ratio or a specific humidity. It is going to remain constant. The state point moves horizontally to the right on the chart. Relative humidity drops only because saturation capacity increases with the temperature. This is very true. If you plot it on psychrometric chart, you'll understand what I mean by this. The absolute moisture content of the air leaving the heater is identical to the moisture content entering it. I tell you, off late, I'm consulting for one company. Raghavji, can I take 1 minute from here to share my practical experiences?
Yeah, please go ahead, sir.
Yeah, thank you, sir. Thank you. So off late, I'm consulting for one company, and there one of the very severe issues is that, they have put in, fresh air content, dehumidification coil, designed for 8 row deep, and they have put in, an HRV wheel. And what is happening is the upper part of the wheel is, removing the moisture, but the lower part of the wheel is actually not removing the moisture only. Now, what exactly is happening is that, stratification is occurring inside the air. And, because of the stratification of the air, the complete and the density variation, the air is falling at the bottom, and it is creating, very sluggish, it is in fact swamping the entire, ERV wheel, because of which the wheel is not able to remove. And, my personal opinion, as far as, ERV wheels and, other parameters is that, the coil is a far better medium of, removing the moisture compared to, removing it with the wheel. But anyways, we are discussing about the heater. So heater is also act as a reactivation, system for, desiccant cooling, etc. It reactivates the desiccants, and then accordingly the moisture is removed, and it is dropped down at the bottom. So per se, if you talk about moisture removal from the heater, no, the answer would be 100% no. And I'll prove that with the help of psychrometric process and numeric examples. So of course, on the after heater, if you place the heater at 15 degrees C, you just look at the psychrometric chart on the left, and after the heater it is 24 degrees C. Once you deploy the heaters here. So working example is if air is entering at 15 degrees C dry bulb temperature, 80% RH. So the calculated specific humidity would be 8.6 grams per kg. Heater adds a sensible duty only. So air leaves at 24 degrees C dry bulb temperature. See what the heater has done. It has increased the dry bulb temperature, but humidity is, leaving humidity, that is humidity ratio, is unchanged. So this is what the answer is to your question. So leaving RH drops to roughly 44%. And purely warmer air can hold more moisture at the same absolute content. So if you remember my talk on RH, that RH value, if you increase the dry bulb temperature, it can increase or decrease. So this is the one of the key factors why this thing is happening. No liters of water were removed from the upstream at any point in this process. So even if you are adding the heater, it will not remove any, moisture. Only the factor that you'll get is, you'll get your DBT raised. So this is proven with the help of, of course, you can, if anybody wants to refer to the calculations, etc. Article I have already worked on, and, maybe you can, subscribe to my, my WhatsApp, channel, and you can see the calculations. I have already posted it. So maybe Raghavji, if you can share my WhatsApp channel for the people to refer to the articles, and, my WhatsApp link in the chat messages as well, like a LinkedIn profile link, and my WhatsApp channel link, both the links, if you can share it to the audiences.
Yeah, I'm doing it right away, sir.
You can, refer the articles,
Yeah.
Thank you, sir. Thank you.
It's already pasted in the chat.
Yeah. Thank you, sir. So, true dehumidification, comparing the options, electric heater, moisture removal is 100% no. Mechanism is sensible heat only. That is omega unchanged, RH false due to warming. And typically UAE use, what it is used in UAE, that is reheat after cooling coil, frost protection. You see a lot of, like frost formation, etc. Right? So this can, reheating can actually prevent the frost formation, because as I was telling, as I was quoting the example for our, EN 1886, that, 20 Kelvin difference has to be maintained between the inside and outside. So if you reheat the hair, using the electric heater, then probably you are reaching the conclusion, dropping the, that delta T variation. And because of it, the frost formation will not happen, A cooling coil below the dew point, yes, it condenses moisture on coil surfaces as, air cools past dew point, primary dehumidification in most FAHU / air handling units, So basically, coil is better medium to remove the moisture, you can go for, 4-row, 6-row, 8-row, 12-row deep coils, and then, probably you can remove the moisture, not with the help of a heater, So the key takeaway from this is, if a space has a moisture problem, look for a mechanism that intersects the saturation curve or a desiccant surface. Heating duty alone can never appear in that solution set. Please take this key away. This has been reached after a lot of, conclusive discussions with a lot of experts, and I reached that conclusion. So next is why do supply air grills, sweat, and what actually causes it? Any surface at or below the room dew point will condense moisture. Condensation is a symptom, not a root cause. Grill sweating means a surface temperature has dropped below the surrounding air's dew point. The fix is rarely the grill itself. It's almost always an upstream airflow, insulation, or control issue. These three have to be taken into account. It's not always insulation or what do you say? The surrounding air is actually very important for understanding this. Okay. So diagnosing correctly means, finding the room dew point first, then asking why a surface fell below that. So as I was telling, diagnosing it, it will mean a lot. Correct diagnosis has to be there. So here, the common causes, for condensation on, supply grills is that, surface temperature below room dew point, the direct trigger, poor or missing insulation on ductwork and grill necks, high room relative humidity from inadequate dehumidification, improper air balancing, low airflow across the diffuser phase, pure diffuser selection, and so on. That is, improper control sequencing of the coil wall modulation or not tracking room RH. And next slide is troubleshooting the checklist. You can actually all these 5 parameters you can take from measuring room dry bulb temperature and RH to calculate the dew point, and then walk through review chilled water set point and control sequences, and then accordingly you can troubleshoot the entire condensation part. So moving on with the next part, which is a single wheel plus heat pipe versus double energy recovery wheel. Single energy recovery wheel plus horseshoe heat pipe. Wheel handles total, that is sensible plus latent, and energy transfers between exhaust and supply. And if I compare the same parameter with the double energy recovery wheel, two wheels in series, total sensible plus latent recovery effectiveness. So here slightly difference is there. Exhaust and fresh air both, and here the effectiveness is measured. So heat pipe adds a supplementary sensible pre-cooling / reheat wrap around the cooling coil. And next is a higher recovered energy translates to smaller downstream cooling coil requirement, and a lower first cost and in a smaller footprint than a double wheel arrangement. The area, if you compare with the single energy recovery wheel plus horseshoe pipe, and if you compare it with the double energy recovery wheel, the footprint is higher, and the capital costs are higher. So I have just given it a performance comparison. In terms of the numbers I have put in, a sensible recovery effectiveness is between 60 to 70%, and double energy recovery wheel is from 75 to 85%. And likewise, latent recovery, effectiveness is, from 55 to 65% and 70 to 80% for the double energy recovery wheel. Maintenance complexity than a typical simple payback versus no recovery. So probably you all can refer to this chart, and it is very self-explanatory. So, and of course the recommendations are that default to single wheel plus heat pipe for typical commercial FHU. Please mind it, if somebody can refer to my calculations, those calculations are very precise with that worked example, along with the formulas and standards from where I have taken the formulas. That forms a very standard basis for my recommendations, and it's already posted on my WhatsApp channel and of course on my LinkedIn profile as well. So just refer to those calculations, and you'll be able to reach to a very conclusive end. So moving on, can indoor plants meaningfully improve indoor air quality in mechanically ventilated buildings? Not at practical densities. Plants help marginally with VOCs, okay, but cannot substitute for outdoor air ventilation. And this is logically, correct as well, because a mechanical device, cannot match, something which is, grown naturally. Of course, NASA has already done a study in 1989, and a clean air study was launched, which measured, how much of VOC, that is volatile organic compounds, uptake in sealed test chambers, and the conditions far removed from a real ventilated office. I mean, the conditions are very different, but still, the data, it shows that IOQ improving with the help of the plant is very minuscule compared with the mechanical equipment or the device. And and the amount of the density that is required for the plant to be planted is too high. So it becomes next to impossible for the building to actually have those plants and then accordingly control the IOQ or the VOCs, etc. And I have proved it with the help of the calculation as well. If the plant is there, it's producing so much of oxygen, etc., and VOCs. And then if you compare it with the FHU or any mechanical device, so will it improve? The answer is no. Practical densities are too high. But one good thing is that plants also release moisture through transpiration, which can raise local humidity ratio in purely ventilated corners. But this is not. I would not like to be on the bandwagon of green and a green brigade or ecosystems. My calculations are throwing the results only for the practical applications in the commercial segment. But plantations, I would definitely recommend if you can go for the green plantations, etc. And if you can plant forest and if you can plant the trees, that will indirectly cut down on ventilation requirements. So, but the practical solutions for the indoor plants, no, it is not possible to reduce this. So why plants cannot replace ventilation? Chamber type, sealed, no air exchange, and a real mechanical ventilated building continuously outdoor air per ASHRAE 62.1, then plant density is 1 plant per 9 to 25 meter square sealed chamber would require dozens of plants per occupied rooms. So that is like, it is not possible to plant dozens of plants within one room, right? And CO2 control, not the primary study focus. NASA concluded that that was not the primary focus. But like here requires active ventilation. Plants are net negligible. It is net negligible. In fact, practical IOQ drivers not applicable. Isolated tests. Outdoor air rate filtration and source control should be there. So practical guidance is that plants are valid biophilic design and well-being feature. But IOQ compliance must always be, delivered through ASHRAE 62.1 ventilation rates, filtration, and source control with plants as a complement, never a substitute. It cannot substitute inside for the, like indoor conditions. So practical design tips, I would like to talk on. The top mistakes, the psychrometric and humidity control people are doing out there in UAE and in other places as well in India and in fact all across the world, as I like to put it that way. Sizing coils and dry bulb temperature alone. Please do not size the dry bulb coils on your dry bulb temperature alone. If you are sizing your coils, and if your dehumidification is required, please go for the enthalpy calculation. Not only sensible or like a mix of latent, but actual calculated value should be enthalpy. And reusing SHR rules of thumb from dry climates. 0.75 to 0.8 SHR, that is sensible heat ratio assumption, from temperate design guides misrepresents the Gulf coastal latent fractions as well. Like the confusing RH reduction with actual moisture removal. As shown in table 2, heating lowers RH without removing a single gram of water. So treating dew point as a static one-time design value. So probably you can refer to this slide as well. And the second top mistake slide is designing fresh air like treatment at peak dry bulb temperature instead of constant wet bulb temperature. Then you can probably if you just drill down under insulated ducting work in high humidity plant rooms and risers, skipping heat recovery or fresh air fraction systems, then treating tab and commissioning as a formality, not as a not as a commissioning as a formality, but as a verification step. Then let me bring down to your case study. Retail malls, I have done already a case study on this. Persistent grill was occurring. The scenario was here. A UAE mall reports recurring condensation on supply grills near main entrance, worst during summer. Like the people were entering, and from where the entrance was there, during the summer evenings when footfall was peak. I mean, the maximum number of people were coming and going. Insulation was replaced twice with no improvement. And continuous condensation was like sin. So of course I have already shown you the root cause, but I would have really requested a poll from the people what would have been the cause for this. And I was thinking to do that and to ask Raghavji regarding a poll, but nevertheless Raghavji, how much time is left for the webinar? Any idea?
You can continue, no problem, sir. People are more waiting for the Q&A.
Acha, okay. Thank you, sir. So, here, the likely root cause was, door-induced filtration at the entrance spikes. Local, RH well above design during peak footfall, and raising the local dew point above the grill surface. Temperature that was correctly sized for designed condition RH. The fix is an entrance air curtain and infiltration control, not the more insulation. You understood what this means. RH is increasing, and because of the RH, the condensation is occurring, and because of the condensation, this grill is actually having the condensation. So this is how the actual problem is. So what they did was they installed an air curtain a complete air curtain was installed, and that is how the complete, the moisture, that is the sweating was on the grill surface was controlled. So it was never around, like insulation. People will say you replace the insulation, but it is actually never it is about the insulation, but the calculation is something different. So this is one of the very critical case studies, inside one of the malls in Dubai, And office towers, the case scenario number 2 is, it's an office tower, high energy bills despite new chillers. What they did was, an office tower upgraded to high efficiency chillers, but energy bills were, constant. It was not improving. They were surprised, why. And tenants were still complaining of, clammy, humid conditions on, a floor, etc. And, the set temperature points were not being met. So, then, we analyzed the root cause, and, we found that, the chiller efficiency addresses sensible plant capacity, not AHU level as a sensible heat ratio mismatch. See, if you replace the chiller plant and, if the mismatch is there in your AHU coil sizing, how are you going to solve the problem? So you understand, people have got of, popular fallacies are there that, if something is not working, you replace this, you replace this, you replace that, that is not the correct way of, doing it. We have to actually take into psychrometrics into account and do the calculations, and then accordingly, reach to the conclusion. The first and the foremost should be, the design criteria, of the entire machine. And then only, this has been a very big this thing. They spent a lot of money onto this, and unfortunately, I came to know only later that people have done this kind of miscalculations, and they have. But anyways, that's a history. So temperature set point is met while humidity ratio stays high. Classic low SHR load on a high SHR coil system, and retrofit, coil reselection or reheat based dehumidification control is required, not a plant level upgrade. So you understand the difference now, how the psychrometric, systems are, calculations, how it is throwing very important challenges inside, So with this, I have covered a lot of, 6 threads into one discipline of psychrometric as an applied engineering. And the key learning points you can take is humidity, energy recovery, condensation, FAHU design, practical engineering, and psychrometrics. So, these are the key learning points. And of course, I have already included, the formula cheat sheet. So I'll post this entire presentation of mine on my LinkedIn profile for the people to refer. And, I think that can be a very good point. Maybe I can, share this and on my LinkedIn profile in one of the posts or something like that. And please do leave a comment on my LinkedIn profile as well. How was the webinar? And thank you very much. And, I leave the floor open for, question and answers. But, I would specifically request, audiences to ask me the question related to, the presentation which I have done. And right in the advance, I'm telling you, there are so many factors, so many permutations and combinations. Even today, when I try to solve a problem, I get stuck up. So if I get stuck up during any of your questions, please excuse me. But one thing is very certain, please send me a message on my LinkedIn profile. I'll certainly send and reply to that. But immediately, if I'm not able to answer, I'll certainly get back to you. That's my promise to you. So with that said, my name is Harshvardhan, and I'm a technical consultant. And if you want to, what do you say? You can send it, a connection request. That is linkedin.com/in/Harshvardhan HVAC. And if you want to search me on LinkedIn, you can search for, my name, that is Harshvardhan. HVAC is the search term. I have included that specifically into that. So with that said, end of the slide. And, Raghuji, if you want me to open the floor for, what do you say, for Q&A, I think I'll be more than happy to.
Yeah. Thank you so much for a detailed webinar. And psychrometry is one
I think longer than I had
comes.
expected.
Yeah, so psychrometry is one subject where we need to continuously practice. Then we'll be an expert. Like Samir, Samir, can you were raising a hand during the presentation? Go ahead.
Hi Harsh, good evening.
A very good evening, Samir ji. Your
Harsh.
name is Samir, right?
Yeah, my name is Savir.
Yeah. Thank you.
So basically, Harsh, I think first of all, I would like to thank you, Harsh, for sharing your knowledge. For sure, it is really insightful, whatever you shared. Certainly, I had one question, Harsh, when you were speaking of the FHU, the heater to be added in the FHU after the cooling coil, I believe, isn't it?
Yeah, reheating. That is like if you want to include the reheating. So what happens is that air becomes heated. Of course, your dBT will rise, but ultimately the reheated air will not form any condensation on the grill surface, etc., and you'll get the perfect outcome. Okay.
So basically, Harsh, what I wanted to understand was, so ideally you're explaining the logic there. If somebody adds a heater, what's going to happen? Otherwise, you're not of an opinion that adding heater is not a good point, isn't it? Because heater should certainly be there to raise the temperature.
Samirji, let me clarify that for you, sir.
Yes, please.
There is no generic rule for design of the product. It's on specific to that particular location requirement and what the people want. A heater may be a good example in some case, and it can be a bad example in other cases. So I really do not have any idea what kind of situation you're dealing with. But my experience says that like if you want to add a heater, go ahead with adding the heater, but do it with the calculated and informed decision. That is only point which I would like to raise. So maybe your condition may demand addition of the heater, so you can add heater, and other conditions may not demand the addition of the heater, so we can remove that. So hope I'm able to do the justice to your
Yes,
question.
yes, yeah. I mean, obviously, because I was when I was reading the slide, I was a little confused, Harsh. So I thought of checking with you, but now it's clear to me. Thank you.
Yeah. You're welcome.
Thank you, Samir. So the Mohammed Khalid, go ahead.
So one of the project we while designing the package air unit, our indoor design was based on 4629, and then we were struggling to check whether the fresh air should be introduced at 4629 or 3432. So just wanted to know which will be the feasible outdoor air parameter conditions there.
Now, that's a typical consultant question. See, understand, whenever you're designing something of that nature, you always go with the enthalpy, sir. And if you're talking about, like a packaged air, the first and the foremost, that was the reason, I wrote that post on LinkedIn. It's a very popular misnomer that, 46 and 30 would be an ideal compared to 34 and 32. Do the enthalpy calculation, whatever like site conditions are there, whatever RH values, etc., that you are getting as per the local UAE's meteorological data points, design according to that. Understand?
Thank you.
See, ultimately, do the calculations. There's no specific point on which you have to design. Do your calculations, find out the maximum enthalpy, and design accordingly. Calculation would be the key. You got that subtle point. You got that subtle point, right?
Yes.
Calculation would be the key. Yeah. So, thank you. That's a very.
Hope your question is clarified, Mohammed Khalid.
Yes.
Okay, I can just answer some information if required.
Yeah, please go ahead.
Yeah.
And I think, Harsh, sorry, I'm just taking some of the information. Okay. Khalid, what was your question? Is like adding fresh air to the system? Is it? What is it? Just one time explain to me again.
there was a prayer room where we had to design with the package air unit, and the temperature at which we selected was 4629. And the fresh air, most of the suppliers were introducing at 46 also, but other suppliers were introducing the fresh air at 3432. That was my concern, because if we are
Are you
introducing
talking about 100% fresher unit, package unit, or 10% fresher package unit, or which one you're talking about?
10% fresh air, 10% fresh air for the package unit.
No.
Okay, so when it is
you cannot. No. That's 10% fresh air at 34th by 32, and remaining at 46 and 30. That is not acceptable.
No, he's taking 90% as return air, and only 10% he's taking as the fresh air. So,
Only 10%
Khalid, what's your
fresh air.
question? Is like
90%.
for you on the selection or the heat load? What is your question? Package unit selection. Package unit
Yes.
selection.
Yes.
So they are going to take the, what is your room temperature and condition?
2417.
Okay, so you are taking 90% of the air at 2417, and you're trying to mix 10% of the fresh air at 46 or 34, correct?
Yes.
See, what
So
others are
10%.
doing is,
No, that's if I were a consultant, sir, Tulsi Raman, right?
Yeah,
if I'm
Tulsi
reading
Raman,
your name
yeah.
correctly, sir. Okay.
Yeah.
Okay. You're from which company, sir? When you're working as a consultant, or how is it like?
see, I have my business, Maven Trading. Okay, I have it in Qatar, Bahrain, and stuff. And also, and I'm the Israel Regional Chair for GCC. Okay, Raghavan, is my friend, so he just sent me this. I just, came in.
Okay. Nice meeting you, sir. Nice meeting you. Nice meeting you, sir. So, sir, see, please understand. Don't mix two data points at one, go. If you want to achieve, 24 degrees C inside the conditions at RH between 30 to 60 degrees C, and if you design your package at one at 46 and 30, and another fresh air at 34 at 32. Don't you think if I go with the calculations, the complete humidity control and the temperature control across the coils is going to be very different, right? You agree to my viewpoint?
No,
right?
Harsh, no, see what he's actually his question, I understand. Basically, he is selling package units to a client, okay? He is taking 90% return air, okay? And he is mixing 10% of the air with condition of 46 is the dry bulb and 32 is the wet bulb, okay? Sorry, 30 is the wet bulb, okay? And the competition, what they are trying to do, okay? They are taking the same 90% fresh air and trying to, mix 10% of the air. Basically, they are trying to arrive at the mixing condition. So when they arrive at the mixing condition, the competition dry bulb temperature on coil will be less compared to 46 degree he is taking and 34 they are taking, okay? So, and obviously, when they are trying to take it at 34 and 32, the latent load is pretty high compared to 46 and 30, okay? And package units, we have to see how much latent load is the coil able to remove. Khalid, what is your other question is like, what did you achieve? You meant to say your on-coil condition was higher, you ended up selecting, on-coil is higher, you ended up actually selecting higher capacity. You will get higher capacity in package unit actually, compared to having lower on-coil actually.
What?
Well, you can, Tulsi Raman sir, you can calculate the latent load, it's very simple, and accordingly select the, it's not a very complex problem. I don't see any complexity into that. If you just plot it, on the psychrometric chart, or, if you can just, use the formulas for the calculation, you'll be able to reach. Just do the calculations and calculations. I've already put.
Sorry. See, there's two things. I think, one is the heat load, other one is equipment selection, okay? If you're doing the heat load, okay, so, and you take the fresh air ventilation load of 10% at whatever is the CFM, and you did 46 and 30, obviously your total cooling capacity required will be lower compared to when somebody takes a heat load at 34 and 32, okay? And imagine you arrived at what is the cooling capacity, what you require in the room. Now, you arrived at what is the capacity, okay? And you also arrived at what is your on-coil condition to the package unit. Then, you might be choosing a package unit which is, for that particular ambient, and then the capacity what is required. So, now, his question, I think, is figures out mostly into the selection of the equipment. I don't think, they're doing the heat loads, actually.
Exactly. Yeah.
If they're doing the heat loads, then they require...
There is an ambiguity. Yeah, exactly.
Yeah.
Exactly. So,
Though at 34...
sir, what you do, sir, you connect with me on LinkedIn and send that question to me, and I'll try to kind of, drill down on his request.
Sure, will do, sir. Thank you.
If that can be. Yeah, you just write it down. Maybe you're not able to express something, or but once you begin to write, you'll be in a much better position to kind of explain. Written I always prefer. Now, if somebody can send me a request, I can drill down on those topics, and I try to. This is what Raghavji was also a lot of times. He sends me all those questions, etc. So
thank you so much for your valid inputs, Mr. Tulasiram. Next question is Mohammed Mohsin.
Yeah, thank you, Harsab, for a wonderful this thing, and Raghav Sab for arranging this. My question is simple. I have on my project, it is one auditorium. So auditorium is below the finished floor level. There is a moisture content ingress from all around the world. There is no water treatment or rainwater, something like dewatering system is not there. So for this, I had selected AHUs and added heaters to that. So exactly what you told us, DVT is increasing, and up to 10 to 15%, I was able to reduce the humidity. Certainly, the project is under construction still. So what would be the outcome based on your experience?
Sir, what I feel is, if it is an underground, auditorium, a lot of, moisture needs to be removed, because once the occupancy load goes high, the perspiration, the sweat, along with, the underground and, the ingress from all the sides, it will increase. So you really have to, do a very theoretical, precise calculation for removing of the heat load, and accordingly, the dehumidification process would be increased. So I don't have, the calculation base, but, if you can send me any details, etc., I can help you with the calculations and, reaching some conclusions, So my take on this is, if you are able to remove only 15% of the moisture as you claim, right?
Yeah.
15% of the humidity. Yeah.
Yeah, 10% it is.
When 10%, and the moment a fluctuating occupancy would happen, what will happen to the basement auditorium, right?
Yes.
So a strong, very strong dehumidification needs to happen. What is the size of the auditorium, sir? Is it big or
how capacity of almost 590 seats?
Acha, 590 seats. So yeah. 590 seats is approximately how much? How much is the area, sir? If I can ask.
Area, I can tell, sir, 40 meter in width and 12 to 15 meter, 40 meter in length. And
yeah, it's a big area. It's a big area. Sir, you have to be very precise with the calculations. And I see that, you may not achieve basement, if you're talking only in terms of, 15%, moisture removal or, humidity removal. So here, very strong dehumidification would be needed, and probably you'll have to go for, not 1 or 2 dehumidifiers, probably, 4, 5, 6 dehumidifiers would be needed. That you can arrange and, you can talk, but one advice I would like to give you, sir, focus more on, what do you say, your low SHR coils,
Okay.
So comfort conditions are, between, 70 to 80%. But, if you take it, below, 70 to 80%, maybe around 50, 60 somewhere. Of course, you can know the data after the calculation. This can, give you a very precise humidity control. And, there are 3 mechanisms for, dehumidification. One is using the coil, and the second one is using the HRW wheels, So I rely more. It's my personal experience that, relying more on, coil as a dehumidification, because there with chilled water application, delta T I can vary, I can vary, number of fins, that is FPI count, then, number of rows. So all these variation and permutations and combinations, it gives me a lot of flexibility. Whereas in, HRW, where the wheel rotation is only, like 15 to 20 rph, revolutions per hour. The humidity removal rate is really slow. So if I were to bank between these two things, I would certainly go with the chilled water application one. Second is for the latent heat removal, coils would be my ideal solution for this. So hope I have justified your question,
Yes.
sir.
Thank you, sir.
Much, Yeah.
Mr. Kiran, you have a question? You have raised your hand.
Yeah. Hi, there, sir. It was a wonderful.
Yeah. Hi,
presentation.
Kiran.
Yeah. So I had one issue in one of my projects. Actually, I was just working for a villas which were near the seashore. These are based in Dubai only. So as per the sustainability consultant, they advise us to take an infiltration rate of 0.2 air changes per hour for all these cases. So
Kiran, can you come again? I cannot hear you properly.
yeah. So can I audible now?
Yeah, you are audible, but a lot of background noise I am hearing, sir.
Yeah. Okay. So my question is actually, I am working on the villa project, which is nearby the seashore. Okay.
Okay.
So basically, a sustainability consultant advised us to take an infiltration rate while doing the cooling load calculation at around 0.2 air changes. Okay.
Okay.
So as these villas are near seashore, so there will be an infiltration from the outside, which will be coming.
Obviously, yes.
Leakages.
Ingress and infiltration load will be, yes. That you have to check.
So,
yes, very true.
yeah. So do I need to do a separate infiltration calculation as it is nearby the seashore?
Yes.
And
Yes.
will it affect your will it affect the indoor conditions like the sweating and all?
Yes, definitely, yes. And it has to be, the infiltration load has to be calculated, and it has to be taken into account in the complete total heat load calculation, and then accordingly the equipment has to be sized.
Yeah, so you mean in
Definitely, yes.
calculation, I need to take those the things in my mind.
Yes, definitely, yes. Definitely, yes. Ingress loads are, I don't know what all the RH percentage, etc. But infiltration loads. See, I was consulting for seafood processing plant, and the moment you go below 45% RH, ingress loads increases to the seafood from the walls become too much. So, you have to take into account, what conditions you are maintaining, and accordingly you have to look into those calculations.
Yeah, because we have submitted the concept for this project actually to the client. So they have commented specifically on that point, like how you are going to tackle these infiltration rates. So just I wanted to get a clarity on.
Certainly, yes. A calculation sheet would be needed to, optimize your size.
Okay. Thank you, sir.
Thank you so much, Kiran. We have Tokozani. You have raised your hand.
Yes, sir. Thank you very much. Good afternoon.
Good afternoon.
Very good afternoon.
I think my contribution will be similar to your first person who asked the question. With regard to the adding of a heating coil, one application will be, I think, when you want to achieve something over like 38 degrees, because your normal air handling unit cannot achieve 38 degrees, is it? I'm asking, sir, Mr. Harsh.
Yeah, no. Can you come again, because I got slightly.
So I'm asking if your normal. I'm asking if your normal air handling unit cannot achieve 38 degrees, for example, is it?
How much degrees?
38 degrees.
80? Sorry, come again.
38.
38.
Yeah, so you cannot get that one from your normal air handling unit.
What unit of temperature is that?
No, I'm asking, so if from the normal air handling units, can you be able to achieve a temperature of around 38 degrees?
88 degrees, it is centigrade or Fahrenheit? It should be in the Fahrenheit. Let us take it as Fahrenheit.
38 degrees Celsius.
No, Celsius, their question is not Nowhere in the world you will get 88 degrees centigrade temperature.
Yeah.
You will get.
38. He said 38. 38.
He said 38 degree C.
Yes. 38,
If I understand it correctly.
Maybe you can post it on the chat. We will respond
No,
to
it's
you.
okay, guys.
You have
He just wants to actually. There will be some application where they wanted an outlet temperature of 38. There are some heating
okay.
applications they want to maintain very high temperatures of
You
45, 50
can
degrees. Okay.
So
It is just that
definitely you can.
during winter,
Reheating of the air would be needed.
obviously you will not get. Okay, you need to have a heating coil. Otherwise, where the source of heating? Okay, only source for you is coil is only for cooling. Unless you provide a heating coil with the hot water is different. Okay, if you have only a cooling coil, then it is going to only cool down for you. So during the summer of 46, you might be able to get 38. But if it's going to be winter, it's going to cool down. Okay, or maybe not. It will not cool down, or it'll be the same. So you will not get 38. So the question is, if you want 38, obviously for this winter period also, then you need to have a heater, unless you have a hot water coil.
Okay, downstream the supply ducting, then you add your heater.
Heater, yes, heater with the heating, you can actually, go ahead and, you can generate whatever temperature that you want. So
Okay.
I hope your question is clarified.
Not
Nice.
that difficult.
Okay.
38 degrees C is very much within the range.
Okay, thank you, sir. Thank you.
Thank you.
Mr. Ram. Yeah.
Yeah. Next is Murli Kandiban.
Hi, Harsh. How are you? Hello. Yeah, Harsh.
I'm fine,
Can you hear
Murli.
me?
How are you?
Yeah, good, Harsh. Harsh, my question
I can
is
hear you.
my question is regarding the heater only. Normally,
Okay.
for example, if you are using heater in winter, as we discussed, it will not increase, it will not change any humidity ratio, and it will be balanced. But in summer, in case if, for example, if for example, I have one home and I kept the door open. Okay. And now I hope normally the cooling coil will be designed at 50% RH. And if my door is kept and other fresh air will be entering into my room, right?
50%
At the
RH
time.
for the home condition.
Yes.
Okay.
If any other latent load like pressure is entering into my room, then if I want to control the RH also, what is the solution?
If you want to keep your door open and if you want to control the RH and inside your home, so if it is inside your home, what is the total capacity and how much is the occupancy, etc.? How many people are living inside?
Normally the designed heat load calculation is okay. Means we have designed like door is closed and even occupancy has taken care and everything other parameters are taken care. Sorry for my voice, I have cold. Okay, everything is taken care. But in case someone has kept my door open, at the time other latent load it will enter into my room. At the time, if I want to. Yeah, at the time, if I want to maintain my RH, okay, what is the solution?
If you want to maintain your RH between 50 to 60%, right? That is one thing. And if you want to keep your door open, so what you can do is that solution that comes to my mind immediately is increase the capacity of the your system, and second is if you want to increase your RH.
Sorry, Harsh. Okay, just entering. Okay. Okay. See, here the question is actually okay. Okay, I think Harsh. Okay, I don't want to take your thing. Just to clarify for you. Okay. See, a lot of factors comes in. Okay, is he maintaining positive pressure?
Exactly,
Okay, if he's maintaining positive pressure, if he's having fresh air, then a lot of air goes out. Okay, the temperature is not a problem. Okay, it's just a question of moisture. Then it's a question about okay, the door is open to outdoor completely, or it's in the corridor where it's already having air conditioning?
Outdoor. My question is
Okay.
outdoor, and also
Yeah, if
even if I am maintaining 30% 30 Pascal positive pressure also, if I am keeping outdoor, the pressure will loss.
Yeah, see,
Okay.
the moisture obviously it can enter even in the opposite direction, unlike your
Yeah.
temperature. Okay.
Yeah.
So then it depends on, you need to calculate how much time you're keeping it open, how many times, what is that? There is a calculation for the
Yeah, the
infiltration
complete-
load. Okay.
Correct.
Okay, I
correct.
think
Infiltration, that's
Raghav,
very
sorry,
true.
I think you go ahead. Okay, I think I might interfere more. I think Raghav and Harsh. Okay,
No,
go
no,
ahead.
no, no, no.
Just
No,
check it.
Tulsi Ramanji, I really want to thank you for answering that question, because I was not able to comprehend. The comprehension was a problem for me. Understanding the question itself was a problem.
Okay, see,
Answer and the solution is
then
not
let
a
me just
problem.
give you an answer. Okay. See, there
No,
is a
I
calculation
understand.
for
Yeah.
calculating, what is the infiltration load. Okay.
Yeah. Okay.
You need to check how many times the door is open, how long it is open, and what is the ambient condition it's going to enter. And
Okay.
typically, you find during the peak summer, example July, August. Okay, if you're going to keep it open from 6 p.m. in the evening until 7 a.m. or 8 a.m. or 9 a.m. in the morning, that's where your peak latent load is going to be there. Okay. During the
Okay.
summer, 46 and 30 is in the afternoon. Okay. But at the same time, during the evening time is where the latent load is killing. And the dew point is pretty high. Okay.
Yeah.
So there is a calculation for you to know what is the infiltration load, and then how many times you open the door, how much time you keep it, and you need to take that load into your heat load, into your cooling capacity, and you need to size your coil for sensible latent accordingly.
Yeah. Okay. Fine. I understood. But my question is here actually, the air is entered actually. Okay, and it will my coil is able to dehumidify, not an issue. Then even I need to maintain the temperature also. You got my point? If the coil want to dehumidify, the coil will go to low temperature, right?
No. See, it depends on what is your coil ADP, okay, and what is the temperature, okay. Your chilled
Yes,
water
yes.
or DX coil, it is. Is it chilled water coil or
Yeah,
DX coil?
exactly. Lot of factors. Like we cannot answer at the spur of the moment. Like we the.
No, I can give him an
this
answer.
Type
Just
of questions cannot be.
is it chilled water coil or DX coil?
That is fine. Yeah, the complete the solution has to be looked into. Along with the engineering calculations and other factors as well. The sizing, etc. Like I was talking in terms of like auditorium. So one single factor, if you ask me at the top, about what I can do, when the solution is very comprehensive.
Yeah. Actually,
I'm sorry to.
no issue.
I'm sorry to
I
not.
really appreciate your answer. I got more knowledge from you. Even actually, Harsha, what I'm following is, and sorry, Harsha and Tulsi, what I'm following is, I am keeping I am keeping heat in my supply duct, okay, and I'm keeping my heater in the supply duct. And what I'm doing is, if any more humidity is in the room, what I'm doing is, I'm giving the signal to compressor and I'm making the compressor to overcool. Then it will dehumidify more. Then the temperature will be very less. Like for example, my descent temperature is 14. Like half coil, I'm making it to cool to 12 degree. Then I'm heating with my coil.
Why are you putting the heater?
Yeah.
You're
See,
heating.
the heater.
That's what
simple
I'm.
for you, Murli.
That is also good.
Yeah.
Simple for you. Okay. See, what does the heater do? Okay. The source which removes the moisture, it's a cooling coil, or you should have dehumidifier.
Exactly.
Yes.
Okay.
Not,
Either you should have a
not your
dehumidifier,
heater.
or the other one which removes the moisture is a cooling coil. Okay. Cooling coil does the job of cooling and also dehumidifying. Okay.
Yes.
Exactly. That's
So
the
now
only
by switching on a heater, imagine if your temperature is achieved, your compressor is going to shut down. Then the coil is not anymore cooled, and your temperature of the coil is higher, and the air cannot go below the dew point, and the moisture cannot be removed. Okay.
Yeah.
What you're doing with the heater is saying that I have additional load, sensible load come into the room. Okay. It could be artificially you are telling the system, no, my sensible load is more. Okay.
Yes.
That is, you're artificially creating the heat in the room through a form of heater.
Yeah.
And telling your system that, okay, compressor don't shut down. Please start working more. I need you to work more. Okay.
So
So then you are just trying to remove.
Your energy consumption would be high, and then accordingly, you are creating unnecessary work. So
yes, understood. But that this is not the actually regular case. But this is the case. It might happen like in I have faced this case like in oil and gas. I'm working in oil and gas, and I'm facing these issues. And for that, we are using the
So oil
same.
and gas, you know, if
Yeah,
you look at it, okay, there's a lot of factors also comes in. Okay, if it's
yeah.
offshore, onshore, okay, and if it is, you know, the environment, what is there, and all that stuff. Okay, I would say, okay, Raghavan, okay, you can take it with Harsh. Okay, in case if you guys need some more details, then send it to me. I can help you out
Yeah,
to
Murli, we can.
find those
Thank you.
solutions for
Thank
you.
you so
Okay.
much. Thank you so much, Mr. Tulasiram. Murli, you can be in touch with us in WhatsApp. We can
Yeah, sure.
give a solution.
Sure,
We can.
We
And
can
see, I'm sorry,
we'll certainly
okay, Raghavan and Harsh.
we
Okay.
will certainly
Yeah, Raghu and Harsh, I'm very sorry. I just, you know, interfere in between and taking, you know, taking some of your questions. It just just trying to share.
That's
Okay.
perfectly fine. That's
Ah,
ultimately
no.
it's a knowledge sharing session. It's not about the
Yes.
credit, and anyone can impart the knowledge. You know, that's what my take on is. And you know, the most important thing is that, you know, the Murli's question should get addressed properly. You know, it's not about me, and
Yeah.
it's not about, you know, like user. It's about, you know, the complete knowledge sharing
Yes.
session. And
Even
that is
other
what
people will
TIECON
be benefited
TIECON
with this
stands,
question.
right? Exactly,
Yeah.
exactly. Very true. Very true.
Sure.
Very true.
Thank you so much. And we'll take few questions and then leave maximum 3 now. Mohammed Sagir.
Yes, well, thank you very much to let me in. First of all, thank you, Mr. Harsh and Mr. Raghavan, to organize this webinar and give your insight on this subject.
Yeah.
Okay.
You're
My
welcome.
question
You're
actually
welcome.
is related to the high RH in my recent project. Okay. During the design phase, we have selected the cooling coil to achieve our required RH, like 55%. Now we don't have a required internal load or sensible load right now, because our substation is going to energize, and we don't have our required load. So the problem we are having here, our package unit is not running at full capacity. Okay, we have 8 compressors in our package unit, and only 4 compressors are running. So what happened now? Now that outdoor temperature, outdoor RH is very high. You know, there's a humid here in Qatar actually. So that's why the compressors are not working at full capacity, and we are getting very high RH inside the rooms. And client is worrying why this high RH is there, and they are
So
asking us to provide the heaters.
basically, humidity is high, and you know, did you design it for, you know, peak conditions? Because you know, the moment you talk about, you know, high RH, because of perspiration,
Harsh,
client
actually,
must be feeling perspiration, right?
yeah,
Yes, yes.
but Mohammed, okay, I'll just give you an answer, okay?
Yes,
See,
yes.
a lot of times, okay, if it is DX system, okay, the moment you're going to size it much higher, okay, what it means that it is going to cool down much faster, okay?
Yes.
If your room is actually requiring only 1 ton, okay, but if you put a 3-ton ducted split unit, if the 1 ton requires 1 hour, okay, usually the cooling capacity is always designed, you know, thermal unit per hour, okay? If it takes 1 hour to cool down the space and maintain that, if you put 3 ton, probably you may require only 20 minutes, okay? So what happens if it is only 20 minutes time, it's going to shut down very quick. So oversizing the unit will naturally have higher RH in the room. In your case, what is happening? Since there is a transformer which was supposed to energize, which was supposed to produce a lot of heat, and that heat is not there for you, then invariably your machine becomes oversized. Though it is not done on purpose or it is not a mistake, your internal load is not there. Okay. So when internal load is not there, automatically your package unit size becomes oversized.
Correct.
So it's going to shut down quite often. It's going to shut down very quick. Obviously, the humidity will not be removed.
Yes.
And if you're going to have fresh air inside your system, that fresh air is going to it's going to be a nightmare, okay, for you. So
Yes.
that is one. So you have to just shut down your fresh air completely for time being, okay? At least do that. So if the fresh air comes in, it brings that very high grams per kilogram. And your grams per kilogram, what's allowed is very less.
Yes.
All it needs is just few minutes for you to just dump all the moisture inside, and your humidity shoots up. So close your fresh air for time being, okay? Because you cannot experiment more. close the fresh air completely, because it's just only a transformer room. You don't need to really have fresh air and occupant and all this stuff.
Yeah,
And then tell them, okay, get your system energized. The system is not energized. You want me to test it before the system is energized. Obviously, you cannot maintain humidity. It's not designed for that. Okay, so you don't have a choice unless and until you want to put a dehumidifier into your space. But imagine if you're going to put a dehumidifier, considering the infiltration load, the dehumidifier capacity is going to be crazy. Absolutely. Okay, very big size.
No.
It's not practical for you. Okay.
Yeah, it is not even feasible here. The client don't want it.
So that's not going to be practical because the dehumidifier to treat. And next thing is also the dehumidifier has a limitation on the on-coil condition of the dehumidifier. Okay.
No, dehumidifier, just
If
leave it over your question. The problem is now the client cannot energize all the panel at the moment, and client also want to be a RH to be controlled inside the room.
Close the pressure, finished completely. What is that? Tell him, if you don't have that, you don't have a choice. Close all the sources of moisture entering into the room.
Even
if humidity is high, okay?
Yes.
Yeah, if humidity is high, it's nothing but there is some source of water, okay, is being generated internally, or the source of water is coming.
Yes.
Humidity is nothing but water, okay?
Yeah.
It's just, so you try to close all your sites where the water is going to enter your building.
Yes.
At least you minimize the latent load, okay? So close down your fresh air, close down your other area where you can do it, and something like that. Sorry, you're asking me, you're telling me something.
Yeah. What about the space heater? If we provide a temporary load, as you have answered in your previous question.
Yeah, of course, it'll help you. It'll help your compressor to work more, so it'll help you to remove moisture. Absolutely, yes, it'll help you.
Yeah, to add a temporary space load to run the package unit
compressor. Yes,
capacity.
The compressor, the package unit compressor will be on for more time.
Yeah,
and it'll help you to reduce your RH.
Yeah, so this is our planning right now. Okay, we put a temporary space heater to run the package unit at full capacity to remove the required RH.
Yes, so you don't have a turn. Yes, that's how you're just trying to, instead of energizing your transformer, you're putting a heater and then generating the same heat your transformer is generating.
But the client wants the permanent solution, not a temporary solution, like to put this space heater.
Yeah, tell him to switch on your transformer. If it is no transformer is on, then how you can do it? You cannot do it.
What about the duct heater? Can we do it for as a permanent solutions? If we put a duct heater.
What is the question of, if your transformer design, if it is 5, it's going to be only 3 is working. You designed it wrongly, okay? 2 is not going to be energized. You're already oversized your capacity. And then you increased your pressure too much. So all those factor comes in, because how will you size the duct heaters? It's not again easy. Unless you size the duct heaters to say, okay, the moment the temperature goes below that, okay, switch on, or it's going to be like RH, then you need to switch on. But then again, what is the size of heater? It's going to be much higher for you. Yeah. Unless you generate the same load, how will you do it? See, anything is possible, okay? It's just a question of cost, it's a question of power availability, and everything comes into play, okay? So the solutions are there, typically what we can do it.
Solutions are always there, in terms of the heating or cooling or, like dehumidification, all the solutions can be really looked into. So it's not a very, complex thing that, it's not a rocket science. Mohammed sir, it's not a rocket science.
The main thing is, maybe, Raghavan, what if there is any typical solutions, okay? If they wanted, then, perfectly the solutions can be, worked out based on the conditions.
You can reach out, to either of us, and, we can provide you with the solution. That is not a problem.
First go with Harsh. Sorry, I'm just interfering. I just came in, just to check in for
it's quite helpful insight from your end as well.
No, it's quite helpful. But thank you, Tulsi. That's really nice of you. Yeah.
Because I work on so many solutions. Okay, so I know the system. So anyway, go ahead. Sorry.
Okay, one last question we'll take, and then we'll close the webinar. Harish.
Yes, thank you for this session. I have a question. Why pharma HU cooling coil comes with bypass damper?
It is because, pharma segment, they require always, some kind of, fresh air systems inside. So I was dealing with a few days back for one capsule manufacturing company. So what they did was, like they were taking 10% of the fresh air, and they were bypassing it using the air handling unit, and then they were trying to put it up. So that's the way it is. Pharma segment people are, the standards are designed like that.
Yeah, okay, I'll give you an answer. Okay, see, what is this bypass air? Okay, it means that, see, when the coil is passing your cooling coil, okay, it is going to be saturated fully. Okay, it's going to come out at 95% or 100% or above 90% RH. Okay, when you do the bypass, okay, there is some air which is passing without entering the cooling coil, right? So the mixing air, okay, without adding your electrical heater, your RH is going to be less. In pharma, you don't want the RH to be much higher in the duct. So if the RH, very high RH, start entering to the duct, you'll have mold, fungus, everything being formed. Okay. So usually the indoor air quality, because of that, the heater is introduced in such a way that, the cooling coil cools down very low. Then, to remove that moisture, and then, they don't wanted the high RH, saturated there to enter the duct. So they put a heater like that. Okay. So here the bypass there will help you to reduce the outlet supply RH condition. It is one of the things to bypass.
But they are also using heater after bypass, after this bypass coil.
Yeah, it could be also for winter conditions. If it's for winter conditions, if you want to heat up the room, heater condition has a lot of application also. It's not about RH also. If it is winter, you need winter heating, right? That's one of the source. And then if you wanted to maintain your supply temperature at certain this one, what is the room condition to keep above the dew point? That is also one more source. And for indoor air quality, everything is there.
Got it. Thank you.
So thank you, Tulsi Ram sir, for making my life easy. You took a lot of questions.
just sharing my knowledge. That's all.
Yeah.
Thank you so much.
That's wonderful.
Thank you so much, everyone. And today the webinar was very insightful and with a lot of question and answers. Thank you once again, Mr. Harsh, for your presentations. And it was very detailed and specific to the point. You have discussed in detail, and it has opened a lot of our perceptions, which we had earlier. And we need more such presentations in future from you.
Definitely.
Thank you.
Yeah,
Thank you so
definitely.
much.
I'll keep doing that. And the next presentation, probably we can plan it on, indoor, like environment quality. My research paper is coming out. So I coined a new term called ITACI. So based on that, maybe I can present, a few more topics onto this platform, and accordingly, let the people benefit. But please, audiences, I would like to request you to share a honest opinion about the webinar on my LinkedIn profile, and do share your questions. Certainly, whatever way I can, answer.
Thank you, Tulsiram sir, for your valuable inputs.
Yeah, thank you, Raghun, for inviting me. Okay, I just wanted to get some more technical knowledge sharing to the people. Okay.
Yeah.
Okay. Thank you.
Thank you so much. Thank you.
Thank you.